8, aircraft and flight operations. So first part of the lecture will be talking about aircraft, which we haven't done in much detail, and the second part will be in regards to some of those key elements in regards to flight operations. Now, the focus questions that we are seeking to answer today are: what are the main types of aircraft used in air cargo shipments? What is the role of freighters in the global supply chain? What is the capacity trade-off between a freighter and a passenger aircraft? And what is the importance of understanding aircraft payload range? Our readings this week come from Morrell and Klein, and 1, 2 and 4. I've pulled a couple out and made those optional, so if you want to get some more information in regards to the air cargo industry and how it stands around the globe, the Boeing World Air Cargo Forecast is an excellent document in that regard. And also I pulled another one out which was just a few pages talking about the future of aircraft in air cargo, some new options. That's not necessarily needed to be covered in the lecture itself. So I guess a really good starting point where today what we're trying to do is to build up some more information around your knowledge of aircraft, is to initially talk about how do you distinguish an aircraft. Now, one way you could do it is via a visual representation. So if you looked at the photograph on the screen there, you'll note that it's got some writing along the side. It's an Airbus and it's got a code A320. So that's one way you could do it, and that might mean something or it might not. Alternatively, you could see a similar aircraft with no coding down the side, and you probably would be none the wiser in regards to what that aircraft was. Now, all aircraft are designated by a letter followed by a number or numbers. So, for example, the Airbus A320-100. Now, to give you a little bit more detail on what that actually means, is that the A, as you probably would have guessed, is the first letter of the manufacturer, which is Airbus. So anything with an A is going to be Airbus, in the same way that anything with a B is going to be Boeing. Now, the 320 is the actual model of the aircraft, and that could be an A320, an A330, A340, etc., A380. Now, the -100 relates to the series, and there could be quite a number of series which are not a new model, so not major developments, but perhaps some improvements and some modifications to that original model. So a series is likely to change with some changes in design. So the aircraft might be shortened, it might be lengthened, it might get a side cargo door installed, it might have a new engine. And that's typically what you'd find in the series. Now, all freighters are going to have some additional coding letters at the end of that series number. And those code letters you can see there. F, for example, I guess that's pretty self-explanatory. That's going to be for freighter. C is for combi convertible. SCD is side cargo door. BCF is a Boeing converted freighter, and so it goes on. Each of those designations just relate to a different type of freighter. A PF, a package freighter, a quick change aircraft, or a new NEO, a new engine option. So that just gives you some sort of sense on how you might distinguish between aircraft. The next part is going to cover off on our first two focus questions, which are what are the main types of aircraft used in air cargo shipments, and what is the role of freighters in the global supply chain. Now, I'm going back to a slide that I shared back in lecture 3 because I think it highlights an important point when we start talking about freighters. This particular table shows the international world cargo traffic by type of service. And by type of service, we're talking about either a freighter or a passenger aircraft. And what it tells us is that over this particular period here, a period of 16 or 17 years, freighter percentage of international cargo traffic went from 42% to 46%. So it's standing at about 50% of all cargo moved is by a freighter. Now, why is that important, or why is that relevant? Well, the relevant comes when you look at the percentage of freighter traffic overall compared to all the flights. And what that tells us is that freighters only account for about 4% of total world flights. However, they're carrying 50% of cargo. So they're a very important element to the air cargo industry. And not surprisingly, when you look at the average tonnes carried by a freighter, it's almost 10 times more that of a combination or a passenger aircraft. And I guess if you consider the fact that a passenger aircraft, you've only got access to the belly hold, it probably comes as no surprise. In addition to this, you can see here that the cargo weight load factor, which is the opportunity that you've taken up as a freighter operator, stands at the moment of about 65% of utilisation of capacity, and for passenger flights it's around about 36%. So they're only utilising a relatively small amount of that available cargo space. And some of the reasons why that is the case is that certainly over the recent years we've seen the influx of low-cost carriers. Typically low-cost carriers aren't carrying any cargo, so that's going to reduce the overall percentage that passenger flights are carrying cargo. Also, on long-haul routes, you're also minimising the amount of cargo you can carry as a passenger aircraft because you're carrying quite a considerable amount of passenger baggage. So that other statistic that's worth sharing is that in 2017 the air cargo industry was worth about $100 billion US dollars, of which 90% of that generated revenue was generated by freighters. So once again, just highlighting the importance of the freighter to the overall air cargo industry. As we can see there, express traffic accounted for 43%. The combination carrier freighters that they were moving was 36%. All cargo carriers at 9%, and passengers at around about that 10 or 12% of revenue. Now, this particular slide shows you the 10 most popular jet freighters. This is a pretty recent slide, 2017. And what it tells us is that at this present point in time, currently, the most popular type of freighter is a mid-sized, narrow, or a mid-sized wide-body freighter. And typically they're used on short to medium haul routes. And we can see that the top three there, which is the Boeing 757, the Boeing 767 and the Boeing 737. The 767, which is a narrow-bodied wide-bodied aircraft, what we can see there, they've got 63 of those particular aircraft on order, so they've been particularly popular in terms of a freighter aircraft. Another thing that accentuates the popularity of these aircraft are the fact that very few are stored. Most of them are in service. In addition to the mid-sized narrow and wide-bodied aircraft, the large wide-bodied aircraft is also extensively used. So what we're talking about there is the Boeing 747 and also the Airbus A300. And you can see there quite a considerable number of those in service. However, what we are starting to notice that a number of those are now beginning to be stored. So that's going to change over time. Some mid-sized narrow bodies are also being phased out, and we can see, so not all mid-sized narrow bodies are popular, as is the Boeing 727 freighter. Now, I guess the thing about the Boeing 727, that was released before the 737, 57 and 67, so there's an issue around age of that particular aircraft. And like everything else, aircraft do have an age limit where they're phased out or stored, if you like. And we can see that around about 43% of that particular aircraft has been totally phased out. Now, I'm not going to talk a lot about propeller freighters. I just want to make the comment that certainly for integrators, propeller freighters are a very important element of their business strategy. This particular aircraft that you can see there, propeller freighters equate to about 2/3 of the numbers of jet aircraft. So if jet aircraft's around 1,800, 2,000 aircraft in use, propellers are around about 1,200 in use. So they're quite a considerable segment of the market. And this particular aircraft, I know it's a little bit pixelled out there, but it's the Cessna 208 Caravan. It's the most popular of those propeller freighters. They're relatively small, but they've got a 1.5 tonne payload, which if you compared it to, say, an A320 mid-size wide-body aircraft, would probably be on a par with the same volume of available cargo space. Now, in many ways, if we were putting freighters into categories, we'd come up with 3 categories. And the first category we could call a standard body freighter. You could arguably call it a small body freighter, but we'll call it standard body. And according to Boeing, this amounts for about 1/3 of all freighters that are in service are the standard body freighters. Now, the standard body freighter is typically utilised by integrators on domestic and regional routes and some regional areas like Alaska. Most of the standard body freighters have been converted from a passenger aircraft. And one of the main reasons for that is that there is sufficient conversion feedstock. Now, what sufficient conversion feedstock is, feedstock just relates to an issue of availability. So there's significant availability of that sized aircraft, which makes the conversion from a passenger to a freighter a very viable business. And because of that volume of standard body passenger aircraft being available for conversion, it's pretty unlikely that new standard bodies are manufactured. So very few standard body freighters come from are manufactured new. Usually they're utilising a passenger aircraft. And really the only aircraft that has been manufactured new was back in the early 70s, and it was the Boeing 737-700C, which is effectively a convertible aircraft. So if you can see by those two pictures, in the top picture there, you can see some seats, some passenger seats, and in the bottom one you can see some freight. So depending on the demand for either passengers or the demand for freight, you could convert that to a full cargo option if you wanted, or you could have it as a passenger option. The next freighter aircraft size is what we can call a medium wide body freighter. Now, about a third of all freighters fit into this particular category. Medium body freighters are used by all air carriers, so they're used by the integrators, they're used by combination carriers, they're used by all cargo carriers as well, typically on regional or long haul routes. A particular popular model in this particular category is the Boeing 767. If you can remember when we had a look at that table, it was second in the list and it had about 65 on order. So that's been particularly popular, and it's used extensively by FedEx as well as Amazon Air, DHL as well. Now, more of these aircraft are manufactured new than the standard category, but still the overriding amount of this type of aircraft have been converted from a previous passenger version. Of course, it's worth remembering that not all passenger aircraft make it into the conversion market. Not all of them are suitable to be a freighter aircraft. So that could have something to do with the cabin height, whether there's potential to put in a cargo side door, and also what you're going to end up with in terms of payload and volume could be working against that passenger aircraft then going on to becoming a converted freighter. Large size freighter is that third category. So we've got the standard, we've got the medium, and we've got the large size wide body freighter. And that takes up about 30% of all freighter aircraft are going to fit into this particular category. Large wide body freighters, as was the medium freighter, are used by integrators, all cargo carriers, and also combination carriers. So it's quite a popular type of freighter. Most of them though, which is quite different from the medium and the standard, are manufactured new, as a preference to being a conversion from a passenger aircraft. And some of those new freighters have actually been more popular than the corresponding passenger version. So typically your Boeing 747-8 passenger version ultimately wasn't as successful as the Boeing 747-8F. And that's usually for a number of reasons that make that particular aircraft popular. In this particular case, it had 16% more cargo volume with the same nose door. It met all the noise standards to get it into most of the countries and cities. And most importantly, it was 17% more fuel efficient. Now, if we were going to have a rule of thumb, half of the jet freighters which are moving about were originally converted from passenger aircraft. And ultimately, as we've just seen by going through those various sizes, it depends on the size of the aircraft. And what we see is that as the aircraft gets larger, there's less likelihood of a conversion. Typically, a passenger aircraft is going to be in service for about 18 to 20 years. And if the manufacturer has got all the specification right, it can then be converted into a freighter and have another 15 to 20 years of life. So you're effectively doubling the opportunity with that particular aircraft through that conversion process. Now, that's not to say that passenger aircraft might become available at earlier times. Passenger aircraft may become available 12 years after the launch, for example. However, the economics are more in favour of an older aircraft being able to provide better value because it's cheaper. According to a consultancy, IBA, Boeing aircraft made up the majority of the conversions over the last year. Specifically, the 737, 757 and 767 are the freighters of choice. And that was shown out if we had a look back at that table, and we saw that those same aircraft were the main aircraft in service. Now, when it comes to converting a passenger aircraft, it's a process that's going to take around about 4 months' time of time, and it essentially involves stripping out that aircraft, so removal of all the cabin fixtures, all the fittings, window blinds, everything in there, as well as the structural components. So you're taking out the seats, you're taking out the toilets, you're taking out the galleys, you're taking out the overhead carriage, and then you're completely refitting it with a conversion kit that's going to be suitable for your purpose. Now, typically, those conversion kits are going to be orientated towards the needs of a freighter aircraft. So it's most likely going to include a cabin door, a side cabin door, quite a large one. If you have a look at the bottom photograph there, you can see quite a significant side cabin door. That's usually a prerequisite of a conversion. You're going to have a new, stronger floor structure, given that all you're going to be carrying in there is going to be cargo. You're also going to have some sort of system which is going to lock in the unit load devices, so it would be ball mats and roller tracks to enable you to load in your unit load devices and containers. And all the windows are going to be covered up with some form of metal covers, and that's essentially to minimise the risk associated with fire, minimise any sun damage, and to make ease of maintenance. Now, as I said before, not all aircraft are going to be suitable for a conversion program. I mean, obviously, those airlines that invested in an aircraft are going to hope that when a period of time occurs, when after a certain period of time, probably 15 plus years, they can then on-sell that aircraft for conversion. But it doesn't always work. And a case in point is the A340, which on your screen there you can see it's a 4-engine wide-bodied aircraft. Now, at that particular period of time when that became available, there is very weak demand for the long-haul wide-bodied aircraft. So in terms of aircraft carriers, there is very little demand. So that didn't help the situation. At this particular point in time, the market was more focused, as it is now, on medium-sized narrow and medium-sized twin-engine wide-body types. So what this meant was that the engineering companies that undertake the conversion couldn't come up with an economical solution to provide an affordable conversion program for carriers to take up. In addition to this, there were some structural elements such as the fuselage. There were some concerns that it might cause some centre of gravity issues when it was in operation. And finally, if you have a look on the screen, it's staring at you there, 4 engines, high maintenance costs and also relatively high fuel costs. So that didn't work in the favour of that particular aircraft. Now, just to give you a sense of the price of a converted freighter, ultimately it's a very important component, because if the price of the converted freighter isn't attractive, then it's quite likely that it's unable to compete with a new production freighter. And as I mentioned before, usually as aircraft get older, the price of those aircraft becomes cheaper. So that's a consideration. But there are also other elements such as inputs. So the inputs to fuel and inputs to maintenance. Because we are dealing with an aircraft that's 20 years old, and over the last 20 years technology has provided a lot of improvements in engines, in all manner of things in regards to an aircraft. So that also needs to be considered. So in regards to a target price for a 20-year-old converted freighter, it's about 25 to 30% of the same size of a new freighter cost. So a converted standard freighter is going to cost around about $10 to $12 million. A medium narrow-bodied freighter is going to be in the vicinity of 15 to 20 million. A medium wide body, 20 to 30 million. And a large wide body, $55 to $65 million for a converted freighter. Now you can compare that to perhaps a medium wide body new is going to be about $70 million, and a new wide body at around about over in excess of $150 million. So I guess you could summarise the factors that make a determination of converting a passenger aircraft and making it suitable for and viable includes the opportunity for feedstock. As I mentioned before, feedstock is just an aviation term that refers to availability. So sometimes it can come down to timing. If you're looking for a converted aircraft, it may be that the particular aircraft type that would fit into your fleet isn't available. There isn't available. Other considerations in regards to timing with regards to passenger aircraft could be if an aircraft's coming off lease, it may present a good opportunity to actually put that aircraft up for conversion, particularly if it's 15 or 20 years of age. But also a D maintenance check is quite a significant check. Essentially you have to strip the aircraft, so you've got to pull everything out and put it back in. That might be a perfect opportunity to take on put your aircraft up for conversion. So as a rule of thumb, it's around about 15 years plus is going to make it suitable for the right sort of aircraft age. Another consideration in regards to passenger aircraft, and I probably mentioned it before, and this is to do with payload over a certain range. So short, medium and long haul routes are all going to have different ratios in regards to payload and range characteristics. So that's another consideration. Input prices, so in addition to the cost of the aircraft, it's going to be the cost of the fuel, the cost of maintenance, and also let's not forget the cost of capital. So interest rates is certainly a consideration in that regard. And Also, availability and price of suitable conversion programs. As we saw with the A340, the engineers weren't prepared to come up with an affordable conversion program because the demand really wasn't out there for them to make that investment. Now, when these fleet management decisions are being made, it's certainly not isolated to one of those issues. Most of those issues are interrelated in coming up with that final decision. And any of those decisions might determine one way or the other in regards to what the company does. Just to give you a sense of the conversions over time, this particular chart shows us the conversions of narrow-bodied and the conversions of wide-bodied over a period of time for the last 20 years. What we can see in 2007, very buoyant time for the air cargo industry. It was peaking at that particular point in time, so quite a significant number of conversions of both narrow body and wide body. Of course, that was just prior to the global financial crisis, and in many ways, if you have a look at the growth levels since then, it's been quite levelled out. The same volumes that were pre-2007 certainly weren't there post-2007. So in 2007, when the volumes were significantly high, conversions of passenger aircraft were strongly orientated to wide body. Greater capacity, higher potential payload. However, at the moment, as of 2018, 75 to 90% of all conversions are around that narrow body, narrow body segment that you can see there. Potentially, one of the reasons for the development, this particular development, is the possibility that wide-bodied aircraft just may not have been available for conversion at that particular point in time. But another argument could also be that there's been a strong growth in e-commerce, which is most likely directed around short to medium haul movements, which fits quite nicely that narrow-body type of aircraft. Now, just moving on to a different sort of aircraft that we haven't spoken about. I touched on it early on, and that's the freighter aircraft, which is called the Combi, or quick change aircraft. And of those two photos there, you can see the Combi on top and the quick change at the bottom. Now, these particular aircraft, there's about over 200 built over time, mostly around the 70s. And it was typically, I suppose, at a time where the growth of air cargo wasn't enough to perhaps sustain one aircraft to carry that air cargo, and the same goes with passenger aircraft. So it was really a compromise where you could have a Combi, which is a multi-compartment aircraft which is permanently configured to have both cargo and passengers on the same deck. So they were all travelling together on the main deck. Alternatively, the quick change is that opportunity that, depending on perhaps things like seasonality, and you had higher volumes of passengers, you could convert that all for passenger movement. However, if that changed over time, you could take out the seating and you could put cargo in there to use it more as a cargo-only carrier. Now, there's very few of these aircraft still operating. The only mainstream operator who's utilising Combi jets is KLM, and at this point in time the average age is around about 24 years. So you would think, unless they get some further conversion improvements, they're coming near the end of their working life. And these days, most carriers, there's significant passenger volume not to need this type of aircraft on intercontinental routes, for example. So typically on continent-to-continent routes, the volumes are enough to either have a passenger aircraft and carry a little bit of payload cargo in the bottom, or have a straight freighter. So the idea of utilising the combi and quick change has really gone out of fashion. And if you think about it, seasonality these days more affects air cargo rather than passengers. If you were going to invest in air cargo, you're most likely to focus on a freighter aircraft of a particular size. Now, freighter aircraft, we haven't spoken about a great deal. We haven't touched on the giant freighters. And there's three main companies that operate the giant freighters. Obviously, they serve a purpose because that heavy, oddly shaped, very heavy cargo can be carried by these particular giant freighters. The Dream Lifter, which is the Boeing 747-400 LCF, which stands for Large Container Cargo Freighter. This particular aircraft is utilised specifically for the movement of parts and components of the Boeing 787 Dream Lifter. Now, depending on your memory, I'm pretty sure I touched on global value chains, and I mentioned how the Boeing 787 Dream Lifter is manufactured around the globe. Well, this particular aircraft plays a strong role in the movement of those components over the world to Boeing's assembly plants. 4 of them in operation. They're not actually run by or operated by Boeing themselves. They've leased this out to CMI to undertake as a CMI, which is Crew Maintenance and Insurance contract to Atlas Air. As of at one point in time, it was the largest cargo hold in the world, no longer, but significant volume. Another interesting freighter is the Antonov AN-225. This is built by Volga Depna in the Ukraine, and that when it was originally built, Ukraine was part of the Soviet Union. That's changed over time, and I think it's still the manufacturing facility for Volga Depna, but you'd have to say that relations between Russia and Ukraine aren't great. Only one of this particular aircraft was built, and it's the longest and heaviest plane ever built. The third giant freighter I wanted to mention is one that's, I guess, commonly referred to as the Beluga. It's a A300-600, known as a super transporter. The Beluga also performed that role similar to Boeing of moving the aircraft parts and oversized cargo around the globe. 5 are built and in operation. Okay, now, the thing about passenger aircraft, by now we're pretty comfortable. Look, yeah. The thing about passenger aircraft is that by now we're pretty comfortable with this idea that passenger aircraft are going to carry the passengers on top, and in the belly hold we're going to have unit load devices. So I think that's taken for granted. The big change that really brought passenger aircraft into, I suppose, presenting that opportunity goes back to the 70s when one of the major innovations in regards to aircraft was the wide-bodied passenger aircraft, the Boeing 747. So the Boeing 747 for the first time was presenting a significant volume that could be carried on passenger aircraft, quickly followed by the Airbus A380. What the Boeing 47 was able to deliver was almost 3 times more volume capacity than the previous Boeing 707. So all of a sudden, carriers had up to 25 tonnes of cargo payload space for cargo shipments. And for shippers, this was a major benefit for them, because now they didn't have to wait in line to get their cargo. They had access to a large number of destinations with a large volume of air cargo. Now, despite this, as we've seen, despite all the benefits of having significant volumes of air cargo space, the freighter aircraft have still been able to maintain almost a 50-50 mix in terms of market share of moving cargo around the globe. And one of the reasons for that sort of stands out in many ways is to do with timing. The timing of passenger flights is geared towards passenger requirements. It's not necessarily geared towards air cargo. So in terms of reliability, in terms of I suppose regularity, passenger aircraft don't always or often meet the needs of your typical air cargo carrier. Also, if you're a passenger airline and part of your business is air cargo, it can be quite a challenging process, because you're dealing with peaks and troughs of both passenger and air cargo and trying to manage both of them. Another issue which is, I suppose, kept freighters to the fore over passenger aircraft is that on a number of routes, there's not always going to be significant passenger demand. So if there isn't passenger demand, passenger aircraft aren't going to travel. So that limits the opportunities on some particular routes. And that's why combination carriers, if you like, are able to have freighters in their fleet and can take up that opportunity if it becomes available. If we look at payload opportunities, freighters stand out almost up to 50% more in terms of additional payload opportunities versus a passenger aircraft, because the freighter has got access to the main deck and there's no carriage of baggage as well. And let's not forget, when we compare when we think of special handling goods, whether it's live animals, whether it's hazardous cargo, typically they are things that cannot be carried on a passenger aircraft. So once again, that presents that greater opportunity for freighters. Also, ultimately, when the decisions are made within a passenger airline, it's prioritising passenger requirements ahead of cargo, which once again puts a freighter operator in a better position to move the cargo. So, as I said before, it is quite challenging for a passenger airline to manage cargo, but if it's done well, it can certainly achieve some significant revenue into the business, mindful of and not losing track with the fact that over 50% of the volume is carried by passenger airlines. So it's not without its benefits. Other challenges that passenger aircraft have, and also freighters in many ways, is that it's often difficult to make a decision around the amount of cargo that can actually be carried on the airline, because that's tied in with other issues around weight, such as fuel. It's also tied in with other issues such as what's happening with the weather, the route that you might be travelling. All these issues come into that, which does have an influence on payload. Also, as we know, passenger airlines are focused on the passenger. So they will keep open a flight almost up to the last minute for additional passengers to be added to the aircraft. So that limits the time that they can have cargo ready to go on board. Also, let's not forget, some passengers miss flights, so you could ultimately miss out on some payload. When you're calculating this cargo volume of a passenger aircraft, it's only when passengers and their baggage are on board that you can say, right, okay, we're ready to go with the cargo. Because up to that particular point in time, that decision hasn't been made. And that's going to be made in the last hour, most likely, in most cases. So how does the passenger airline get around this? If you think about it, you really wouldn't be wanting to be in that decision-making process every single day. You've got your cargo waiting out there. You're waiting up to the last hour before you call the cargo guys to bring the cargo into the aircraft. Typically what they're going to do is to say, right, this aircraft is going to operate on the basis of full passenger and full baggage, and that is going to be the set amount of cargo, additional weight, that can be added into the belly hold. Now, I guess what we know is that passengers' aircraft don't always travel at 100% capacity. So that lost capacity, you're missing out on cargo payload, which could go in cargo. When it comes to operations planning, every aircraft that departs on a journey is underpinned by a whole range of operation planning considerations. Now, if you're an airline, you get a lot of guidance by virtue of the manuals that are provided to you by either Boeing or Airbus or whoever the aircraft manufacturer is. And typically, those standard operation characteristics are based around a standard day. So a standard day might look something like an agreed ambient temperature, 0 headwind, standard climb out and cruise speed on runway, and also typical regulatory requirements. So that's your starting point for every aircraft that's on the tarmac ready to go. But what we know is an ambient day would be very unusual in many cases. You've got issues around wind, you've got issues around temperature, you've got issues around things such as altitude. And all these impact differently on every different aircraft. Now, based on that information that you gain through the aircraft manufacturer details, there's a number of decisions that you have to make, and typically what you would do is you would come up with a company policy around how you're going to deal with these type of issues. And each aircraft has got a set amount of characteristics which will impact on the airport that it can go to. It will also impact on the distance it can fly. So there's a whole lot of considerations at that particular point in time. For the air cargo carrier, one of the key issues is this idea of payload. In other words, how much cargo they can carry on that aircraft based on the operational characteristics of that particular aircraft. And that gives us what we can call a maximum payload opportunity for every single aircraft Excuse me. And the maximum payload opportunity is the difference between the maximum zero fuel weight and the operational empty weight. So from here, now the operational empty weight is the weight of the aircraft, including the aircraft itself, the crew, any fluids necessary for the operation, and all operator items and equipment required for the flight. That's the operating empty weight, okay? The maximum zero fuel weight is the maximum weight that aircraft can be before fuel and other additional fluids are added to the aircraft. And that's going to, as I said before, differ depending on the particular aircraft itself. So on this particular example, what we can see is this has been done for a passenger aircraft. So as you can see in here, this is essentially, we're talking about a weight type issue. It's a discussion around weight. And for this particular aircraft, this is the amount of weight in passengers and cargo that it can carry. Now, what happens is that that is going to change over time. So you can't fly long distances without a change in terms of the amount of cargo and passengers that you can carry. So, as I said before, different aircraft types and different engines are going to impact on what the maximum zero fuel weight is. So, in this particular example, point A is the optimum for this hypothetical aircraft in terms of the maximum cargo and passengers it can carry is a range that goes that far. So, a range which is distance. So over that distance, up to a certain point, we haven't got a number there, but that doesn't matter. At this particular point, the maximum zero fuel weight provides the best maximum payload for that particular aircraft. Now, it's worth noting, I suppose, that that is not when the fuel in the aircraft is fully being filled up. It's a point that provides a balance between payload, cargo and passengers, and fuel and the other additional elements. Now, at point B, so as you can see there, the distance is getting longer. So we're on a longer distance. Now, over a longer distance, as you would expect, there's going to be greater fuel burn. So you're going to need more fuel. If you need more fuel, you've got to take something out of the aircraft. So you're impacting on the payload of the aircraft. So that payload in cargo and that payload in passenger is going to reduce. So you could argue that the new maximum zero fuel weight comes down to about there. So that's the amount of cargo that you can carry. Now, if you continue on your journey, so you're going on a very long haul flight, you get to point C. And at point C, you're effectively maxing out the fuel potential of that particular aircraft, and it becomes uneconomic to continue. It's uneconomic to have a route that long because, as you see, it really limits your opportunity with both passengers and cargo. So that's bringing you into that uneconomic zone. Of course, if, for example, you go on a smaller trip, well, you're missing out on this area here of maximising your payload. Now, I'm a little bit reluctant to throw out the question, has everybody got that? But look, I'm happy to spend some... Yeah?
How well do we have to know that?
It's just a concept I'm sharing with you, and it's not something that you will be asked necessarily, but as a general concept, really all we're talking about here is that over time your payload is going to reduce because you have to take out some of the cargo and put in fuel. Now, for a larger aircraft, it's going to be different than a smaller aircraft. So each aircraft is going to be different. So it's just that general concept around that idea. So the shorter route is not going to get you to, in this particular case, your maximum payload opportunity. Now, so what that particular example shows us is that for an airline that's not going to fly one particular distance, sometimes the distance is going to be here, sometimes the distance might be there, sometimes the distance might be there. There needs to be a compromise with the aircraft that they're bringing into their fleet. So it makes that whole decision-making process, just takes it up another level when you consider these type of issues. Now, the short to medium haul aircraft, such as a B737 and the A320, are often used in sectors that are much shorter than their designed range. So what that's saying is that they're probably missing out on some payload opportunity. And in many cases, passenger airlines are flying with perhaps little or no cargo, and they end up paying for that capacity when they're travelling on those shorter or medium routes. And of course, this is particularly critical for the low-cost carrier. So the low-cost carrier who might have a A320 is got capacity for about 1.5 tonnes or 1 to 2 tonnes of cargo. They're flying around all the time with no utilisation of that payload. So typically that's why the low-cost carrier is going to have that short or standard to medium aircraft. Very not very often you would find a low-cost carrier with a large wide-bodied aircraft. Now, a few issues in regards to performance on long-haul routes. Utilising that idea that I presented there before regarding a freighter and passenger, due to the lack of galley seats, a freighter aircraft of the same model is always going to be lighter. So you've got two identical aircraft, such as those two here. They look pretty identical on the outside, but the freighter is going to be lighter because it's not filled with seats, it's not filled with galleys, it's not filled with other structural components which are necessary to be in a passenger aircraft. Now, what that means is that the operational empty weight, which we were looking at a moment before, is going to be lower in a freighter than it is with a passenger aircraft, which means that they have greater opportunity for more payload till they get to that maximum zero fuel weight. So this weight advantage enables the freighter to carry more revenue payload with the same fuel burn. So, for example, once you take all those elements out of a passenger aircraft and it becomes a freighter, it might be, I don't know, 15, 20 tonne. Well, all of a sudden, you've got 15 to 20 tonne additional payload weight to put you on a par with a passenger aircraft. So it's a significant advantage. So from a performance perspective, the freighter on those long-haul routes is going to be ahead of a passenger aircraft. Now, an example would be Frankfurt to Atlanta route. It's a 10-hour flying time. Now, on this particular route, a freighter can take 20 tonnes more payload than a comparable passenger aircraft. And it's because of that weight difference, because it's not carrying that same sort of weight. So that's some sort of advantage you would think. Now, if the passenger aircraft wants to increase its volume, we know it can only increase its volume if it takes on more fuel. And if it takes on more fuel, it's likely to increase the fuel consumption, which is also going to make it an expensive exercise. It's not a linear process, but the suggestion is that for every additional tonne of payload, the additional marginal fuel consumption is about 370 tonne. 370 kilos. So that's quite considerable amount of weight. So to that end, the freighter operator has got at quite an advantage to make their load factor calculations to enable them to improve their towards that maximum payload. Other performance issues for long-haul routes. We know that on a number of those long-haul routes that the trade flows are not always balanced. So we know from Asia to Europe and to and from Europe, and also Asia to and from North America, both those routes aren't the same balance. So in those particular situations, the freighter operator can take up that opportunity of perhaps either flying direct and maybe minimising its payload, or making a few stops in that long-haul trip to increase capacity. Now, for your long-haul passenger, they're not stopping off on a long-haul trip. It's all about a point-to-point and getting them passengers to that point. So it's another little performance advantage of the freighter. Now, if you've got those fifth freedom traffic rights, that's going to allow you to stop at a number of countries, drop off cargo, pick up cargo. It's going to improve your payload in that regard. So, as a general rule of thumb, you'd have to say that freighters are typically going to have more stops than a passenger aircraft. The exception there is if you're an integrator, you're not doing this long-haul short stops along the way. If you've got emergency goods, they need to get into the market in the same way that the passenger does. So long-haul, where payload reduces over distance, and we're comfortable with that, the freighter operator can also add in some fuel stops along the way. It's no issue, you're still getting the goods, so you can have quite a high payload and take fuel rather than taking the fuel at the start of the journey. And this cycle of stopping and going, it only has a marginal difference on additional fuel increases. So that makes that strategy quite viable. Another option that's available, and it's most likely to be taken up by freighter operators, is this idea of fuel tankering. So fuel tankering is starting off on your journey with almost a full fuel tank, and it reduces the need to refuel as you go on your journey. And one of the main reasons why freighters might do this is because in some cases there might be a significant fuel price hike in a particular airport, and if it's a long haul route then it's a viable option. Now, the thing about tankering, it's not all good news. There are some considerations that need to be made in that regard. If you start off your journey with full fuel tanks, you're going to miss out on a maximum payload because you're going to be further down that curve, if you like. So it's going to reduce your cargo payload if you choose that particular option. It's also likely to provide a little bit more wear and tear on the aircraft itself. So it's a heavier aircraft, more wear and tear, and more power required potentially. And also, if you've got a heavier aircraft, you need to be mindful that you're more likely to need a longer aircraft runway, so takeoff and landing distance are going to be longer, with the potential of some additional wear on gear and brakes. So fuel tankering makes sense, but only if there's a big fuel difference. Otherwise, it's probably not such a great idea. And if the journey's short, then fuel tankering is probably not going to be that economically viable. Yeah.
Would that be fuel price and fuel quality as well? If you know that a certain airport only stocks fuel that's worse or better?
Look, possibly. I would expect that the inputs of fuel are going to be pretty similar. It's mainly about price. It's mainly about the fact that you can save yourself some funds in your country versus somewhere else. A couple of other operational issues relate to, I touched on runway length. Every aircraft, depending on their weight, is viable for a certain runway. So takeoff and arrival length is also going to vary depending on altitude. So these are considerations that need to be taken on board in regards to flight operations. So an aircraft with, say for argument's sake, a maximum takeoff weight of say 275 tonnes, at sea level might require a runway of about 3,000 metres. However, if it's high altitude, all of a sudden it requires a runway of 4,000 metres. So this is just one of those issues around altitude and weight. And also related to altitude is this issue of hot temperatures. So hot temperatures with low air density can significantly impact on the performance of an aircraft. Now, in some of those, Bogota, for example, probably Nigeria, most of the air cargo flights out of those places are limited between 12 noon and 9 p.m, which is the hotter times of the day, because indicatively it suggests that you could lose up to 6.5 tonnes of payload if you're travelling during that particular period of time. So your options for avoiding payload is travel in the morning, or travel at night, or only take on so much fuel and then have a number of fuel stops on your journey. So that's the end of our lecture today. We covered what are the main types of aircraft used in air cargo shipments, what is the role of freighters in global supply chain, what is the capacity trade-off between a freighter aircraft and a passenger aircraft, And what is the importance of understanding aircraft payload range? Thank you.